Okay, example 2. The triangles shown are similar. So we know they're similar. Determine the length of the unknown sides. So first thing we got to do is we know they're similar. Do you see 2 triangles? There's 1. There's 2. So now we got to try and match things up. So let's see if we can. Well, the longest side, we don't know which side's the longest side, but there are some things, again, using our knowledge from grade 9 that we might know. Can we match up angles? Well, that angle right there matches up with that one. It says it does. Awesome. Let's keep my color coordinating the same, so B was orange. So if that angle says B, that one matches up with D. The side across the triangle, 10, matches up with the side across the triangle, 12. We also see that vertex A, whatever number that is, alpha, it's same over here. So that matches up there. Again, across the triangle, that's 15, matches up with that side. Which leaves us with the third angle, or the third side. Matches up here. And you might know that if 2 angles are the same, the third's going to be the same. We also remember from grade 9, those angles are also the same because our opposite angle theory, which means C is the same for each side, for each triangle. Okay, so what does that mean? Well, I'm going to label, if this is C, I'm going to use that as a small c, and this side is a small e. So I got to determine the length of E and C. So let's see. The big triangle, I got 15 over top of matching side, corresponding side on the small triangle, E. And that all equals, let's look at B, 12 over 10. But that also equals 18 over C. Now I got 2 equal signs of that line, but this is my starting point. To find E, I'm just going to use those 2. So I look at what I'm going to do, and I'm going to rewrite it here so that we can see. Just like our previous knowledge, I'm going to take the bottom of one side, multiplied by the top, the bottom of the other, multiplied by the top. Cross multiply, I got 150 equals 12E. Divide by 12, divide by 12. And E equals 12.5. So there's E. To figure out C, I'm just going to use those. I'm going to use the ratio that I know and is given. So let's see, that's 12 over 10 equals 18 over C. Now depending on how you wrote it, I could have wrote every fraction the other way around. And there's nothing wrong with that. If I'm going to flip that, I have to flip that as well. So I'm just going to write that over here, and then I'm going to prove that it works. So if we cross multiply, 12 times C, 18 times 10, we have 180 equals 12C. Divide by 12, divide by 12, C equals 15. Now, because C was already there, remember, I don't actually need to cross multiply. If I think about my order of operations, this is C divided by 18. So I'm going to multiply the right by 18 and multiply the left by 18. Now I have 18 times 10 divided by 12. Well, that's that right there. So that gets me right to my final answer is C equals 15. And there's absolutely nothing wrong with doing that. If I kept this on top, and I cross multiplied, I'd have 12c equals 180, and I'm right where I was. So different ways you can set it up. If you're looking for the unknown, I would usually put it on the top. I purposely put it on the bottom here because I wrote the big triangle first, and that's okay. Let's try another example. Given that triangle PQR is similar to triangle TUV, it gives us measurements, determine the length of TU. So we don't have a drawing here to see, so let's add it. PQR. So I'm going to label PQR. Color coordinating might help. So P is going to match up with T. So there's angle P, and there's side P. My triangle, same order, T, U, V. Q is going to match up with U, so there's Q. It's going to match up with U, and leaves R to match up with V. If we now add the measurements that we've been given, QR is 6 centimeters, PQ is 7, UV is 8. Determine TU, right? Remember, TU is just actually little v as well, or side little v. So there we go. So I have my unknown over its corresponding side, and all that equals, well, I started with this triangle, I should continue with that triangle, 8 over 6. V divided by 7, well, let's get v by itself, so 7 times v. All right, so now I have v is equal to 8 times 7, 56, divided by 6. Well, that's going to give me a decimal. I could round. Let's see, can we reduce that? Well, they're both even, they both have 6s. Let's try 3. Oh, yeah. 28 thirds. Which, if we turn it to a decimal, is 9.3 repeating. Repeating decimal is not bad. Thirds, let's keep it as a fraction. Okay? Awesome. So you have these skills from grade 9, ratios. And now we're just applying them to triangles. But this is a skill you've done in grade 9. Let's do a few more application style examples. Measure the height of a pole. James stood 8 steps away. Okay, so that means that that is 8 steps. And notice that his shadow is 9 steps long. That means that is 9 steps long. He knows that the pole, that he is about 12 steps tall. What is the height of the pole? So do you see 2 triangles there? Hopefully you see 1 triangle there and 1 triangle there. Now, this will be the same angle because the sun, really far away, all the light rays are completely or almost completely parallel by the time they reach the earth. So the shadow that the pole is going to cast, that triangle will have the same angle there as it does there. This is the same corner for both triangles, and the pole is standing straight up, or at least where the tip of it is can be 90 degrees to the ground, and James here is standing pretty straight, good posture, 90 degrees to the ground. So again, we've got 2 triangles. We have James, and then we have the pole. And so when we look at that, James, 9, and over here is going to be 9 plus 8, the full length, which is 17. James has a height of 12 steps. How he measured his height in steps with his own feet, who knows? And the pole is what we're trying to find. So let's set up a ratio. X over 12 equals, and I started with the larger triangle, so let's continue, 17 over 9. And then we math. Times 12, times 12. Put that all in my calculator. 17 times 12 divided by 9 gives me a decimal. And that's okay because now we're talking about real thing, how many steps. When I put that in, it's 22.6666666, so 22.7 steps. So that's how tall the light pole is. Okay, the last example for our knowledge and for our understanding. So we're going to determine the scale ratio of ABC to DEF. Okay? And I'm going to do it the other way around. I'm going to actually do DEF to ABC. So we match up sides. So A is across from there. The hypotenuse is going to be the hypotenuse each time. C, the side, is going to match up with, I'm not sure, let's see. Well, the longest one matches with the longest one, so the shortest one matches with the shortest one. I'm assuming that's the shortest one based visually, but we can do it by angle, as you can see, that one is over there. So, scale ratio, how much bigger is the big triangle than the small triangle? Well, we only have to look at one thing. Those match up. That's what's given. So, 20 divided by 1 is 20. So there's our scale ratio. The big one is 20 times bigger than the small one. Determine the missing side. Well, if our scale ratio is 20, and we looked at big divided by small, then that can still hold true for x divided by 3 needs to equal that same scale ratio, 20 divided by 1. Times 3, times 3, and x equals 60 in the unit feet. Cool. Determine the area of each triangle. So remember, what's the formula for area again of a triangle? Oh yeah, base times height divided by 2. So for triangle ABC, we're going to have the area is going to be 3 times 1 all divided by 2. And I'm going to turn this into decimal just for us. So the area is 1.5 feet squared. For triangle DEF, we're going to have 60 times 20 base times height all divided by 2. 60 times 20 all divided by 2. The area is 600 and it's feet squared. It's that unit. So a lot more area. If we need to determine the ratio, and again I'm going to go DEF to ABC, of the areas, what do you notice? So again, I did big triangle divided by small triangle. So let's do big triangle divided by small triangle. And the ratio, 600 divided by 1.5 is 400. Well, what does that have to do with the scale factor of 20? What do you notice? Well, area is squared, so what's 20 squared? Twenty times 20 is 400.